Continuing our work with inverse trig functions, and we're using and applying inverse trig functions. This is the first of several videos. In the previous video we saw inverse sine, inverse cos and inverse tan of x, and we discussed various things about the functions and their graphs, and we looked at basically restrictions on the domain at a fairly light level, and we're going to look at that and explore that a lot more in this video. If we go back to regular old y equals sine x and also cos x and tan x, which we're familiar with, those functions, we know that those being functions, they're many to one. So all of those are many to one relations. Now that goes back to some of the initial stuff you would have learned when you were learning about what a function was, and you might recall that the definition of a function is that basically every element of the domain maps onto at most one element of the range. Okay, so if we have the domain, okay, the set and the range, which is the set of all possible values there, for a function, it means that every element in this set maps onto at most one element in the set of values in the range. So that links to, graphically, it links to, you would have recalled the vertical line test, which basically is the same thing. It's just a quick graphical check. So basically, vertical line test, if you can draw a vertical line anywhere through the function's graph and it cuts through more than once, it is no longer a function. It might be a relation, but it's not a function. And the reason why, if we look at mappings and the difference between a relation and more specifically a function, we cannot have things such that a certain member of the domain maps onto more than one element of the range. With that in mind, we can see that we can have things like many to one, so that means many different elements of the domain can map onto one particular element of the range, and we see that with sine x, because it's a very rough quick sketch. Sine x essentially being a periodic function continues on in this manner, okay, and likewise that way. But if we look at any particular value of the domain, it only maps onto one value of the range. It doesn't matter where you go, but you've got many things can map onto one particular point. So if we look at one point in the domain being, let's say, y equals 0, okay, well, it maps onto y, this particular function, let's say it's sine x. That's just one example. It maps onto y equals 0 there and there and there, and there's an, if we've had a restriction on the domain, there's an infinite number of values, but not just there. If we extended the graph, the peak, it would touch there, okay, the trough there. So that's an example of many different values of the domain will map onto that particular value of the range. So that's a many to one. One to one, that might be something like y equals x or some linear function, and you have an element of the domain mapping onto one element of the range, and that continues on. So that's a 1 is to 1, and then 1 is to none in some functions that have a discontinuity. So they're all okay, but it's, as you can see there, if the big red cross, 1 is to many is not a function, okay, and that would fail the vertical line test, as I pointed out just before. So something like this conic here, okay, it might look like a parabola, but it's not a regular parabola. It's not a parabolic function, so it's a conic or a locus, but the fact is this particular one is not a function because apart from the vertex, anywhere else the vertical line will cut more than once. It'll cut twice everywhere else, and so this particular element of the domain maps onto more than one element of the range. So with our inverse trig functions, let's see why now we have to restrict the domain and what it looks like graphically. We can see we have a couple of graphs, or in fact 3 graphs here. Y equals sine x in the blue, you're familiar with that, and what we have in the red is if we switched x and y around and plotted the inverse relationship, and you'd actually get the same shape, but it's going along vertically instead of horizontally, if you know what I mean. And in the previous video we discussed that they're actually corresponding points mirrored about y equals x. But you can see the problem that would arise, because if we had no restriction, if we look at the red function here, look at the vertical line test, it cuts more than once. In fact, without any restriction, it's going to cut an infinite number of times. So that's a problem. So we have to restrict the domain if we want to consider the inverse, things like inverse sine, inverse cos, and inverse tan x. If we want to consider those as functions, we must restrict the domain, and then they do qualify as functions. The question is, what restriction? Because we could restrict this in lots of different spots, and we would get an acceptable answer. In fact, there are an infinite number of restrictions. For example, we could look at from here, as long as we don't get down to there, if we put an open circle there, and if we use that proportion of the graph, it should pass the vertical line test in terms of those, but then it's still, there's still a problem there. So we're going to need to think this through. So if we have a look at y equals sine x, you can see there in green, and if we look at y equals inverse sine of x, now you saw previously that it kept going. So it kept going, but what you can see, the bit plotted on the Desmos graph is this part here, and we're trying to avoid that vertical line test fail. Perhaps you can see that if this continued on, we'd then have a breaking of the rule, and we'd end up having one-to-many, and that's no good. Alright, so there's a restriction there. Now you can see the reflection bit that I showed you in the previous video. There's the red line, y equals x, and if I just look at showing just part of that graph there, so turn off there, so you can see there this in the lighter red there's part of y equals sine x, the purple one is y equals inverse sine x, and the straight line is y equals x. Okay, so alright, can you see that? I'll just leave that little bit there, and you can see that reflecting nature there. So what do we do for our restriction? The convention we use, and note that Desmos did this automatically, and so will your TI graphics calculators, is from negative x equals negative pi on 2 to positive pi on 2 inclusive. Okay, that's automatically set up in the calculators or the software application. Just changing back to a more convenient scale for the x-axis for the domain, we have 1 and negative 1 are our limits. So the restricted domain for y equals inverse sine of x is from negative 1 through to 1 inclusive. Okay, what I just mentioned before was the range essentially. So the domain is from negative 1 to 1, and the range is from negative pi on 2 to pi on 2. And that is true for y equals inverse sine x. Hence the result that we looked at earlier up here. And next video we'll more quickly go through the same corresponding results for inverse cos and inverse tan. So 2 more videos to go on this topic. The next one will be for inverse cos, inverse tan, and then the last one will be some worked examples to apply.